Good morning, everyone. Today we are going to discuss about the structure of atom. What is meant by an atom? Actually, matter. We know matter. What is meant by matter? Matter means the substance which have the substance which has some weight and occupy some space is called as a matter. The substance which have some weight and occupy some space. Every particle, everyone is a matter, part of the matter. For example, if I take this marker, it has some weight and occupy some space. So that type of substances are called as a matter. This matter is made up of some particles which are called as atoms, So atoms are present in every matter. Every matter is made up with some particles which are called as atom. What is an atom? What is the definition of atom? Definition of atom is a tiny particle. Atom is a tiny particle, very small in its size, a tiny particle, and which is invisible. We cannot see. Invisible means that much tiny it is, and indivisible also. We cannot cut into two parts. We cannot divide into another parts. Means when we cannot divide into another parts means it is very small in size, then only we cannot able to cut it. So that is an atom. Atom is a tiny particle which is invisible and indivisible. Right. Atom, we have one theory, that is a Dalton's theory. What is the Dalton's theory? Postulates. What are the points in Dalton's theory? Number one, matter theory. Point number one, matter is made up of matter. Now only we discussed matter is made up of tiny particles which are called as atoms. Atoms. That is the first point. We know that point. And atoms neither created nor destroyed. Means we cannot create the atom. And we cannot destroy the atom. Atom is a part of chemical reaction. Atom takes a part of chemical reaction. So in chemical reaction which take a part, atoms involved in chemical reactions, then atoms convert from one form to another form. For example, if we are taking C plus O2 gives rise to CO2. This is one chemical reaction. Here, who are involving in the chemical reaction? Carbon atoms reacting with oxygen atoms. They are converting into CO2 molecules. Molecules also containing the atom. So atoms are converting from one form to another form, neither created nor destroyed. That is the meaning of atom. Atom take a part in chemical reaction. After that, and next point, what is the next point is atom take a part in chemical reaction, that we know, and atom of same element, atoms of same element are same, atoms of same elements or atoms of same elements are same. For example, if we take carbon, what are the atoms are present in this carbon? Those all atoms or same atoms, those we are calling as carbon atoms. And for example, oxygen atoms, if we are taking, what are the atoms present in oxygen element? Those atoms are same elements which we are calling as oxygen atoms. Oxygen atoms. These are carbon atoms, these are oxygen atoms. And atoms of different element, if we are taking different elements are different, same. And the above reason we can check again. Carbon atoms, all carbon atoms are same. Wherever you take a carbon atoms are same only. Oxygen atoms are same only. But these two are different. These two are different with each other. Carbon atoms are not like as oxygen atoms are not like as carbon atoms. If these two are same, we does not have 118 elements till now. Only one element will be there, because all elements are containing the atoms. All elements are containing the atoms. All atoms are same means no need of 118 element. Different elements need is not there. So the atoms are there, it is true, atoms are present in the elements, but those atoms are having different properties, different characteristics will be there. Carbon atoms are behaving like different characters, and oxygen atoms also behaving like as another different characters. That is the difference between these two atoms. Not only these two atoms, 118 elements atoms are different atoms in different elements. This is a Dalton's theory. What is the failures of Dalton's theory? Failures of Dalton's theory. Number one, he couldn't explain about the why different elements are having different atoms. He couldn't explain about the why different elements are having different atoms. He was unable to explain about this point. And next one, that he couldn't explain about isotopes and isobars. What is isotopes and what is isobars? We are going to discuss about that. Isotopes and isobars. Isotopes and isobars. He couldn't explain about isotopes and isobars. And the third one is he couldn't explain about Dalton's theory, couldn't explain about subatomic particles. Subatomic particles. What are subatomic particles? What is that? We will discuss now. Subatomic particles. 3 points are there. Drawbacks of drawbacks or failures of Dalton's theory. Number one, he couldn't explain about the why different elements are having different atoms. And isotopes, he couldn't explain about isotopes and isobars, and about the subatomic particles. These are the 3 failures of Dalton's theory. Invisible and indivisible. Now we discussed about in failures of Dalton's theory, subatomic particles. What is subatomic particle? Subatomic particles. In this, subatomic particles means atom is a very smallest particle which is invisible, but for our convenience we are drawing like this. We are drawing in a spherical shape. Atom is having spherical shape only. So in spherical shape. In this spherical shape, again inside of an atom Again, three particles are present. Three particles are present. Three particles are present inside the atom. Those three particles we are calling as subatomic particles. What are that subatomic particles? What are that subatomic particles? Number one, electron, proton, neutron. Electron, proton, neutron. Where it is present, that we will discuss in the models. Electron we are indicating with E. Proton we are indicating with P. Neutron indicating with N, small n, small e, small p. Electron is having negative charged particle. Negative charged particle. If you take a proton, proton is a positively charged particle. And neutron means no charge. No charge means nothing but a neutral charge. Neutral in nature. No charge. There is no any charge on the neutron. So, electron is having unit negative charge. Proton is having unit positive charge. Neutrons are having no charge. No charge on that. The overall charge on the net charge on atom, net charge on atom is neutral only, is neutral, because unit negative charge is cancelled with unit positive charge. They are going to get neutralize each other. So the overall charge on the atom is neutral. What is the charge of electron? Charge of electron equal to minus 1.6 into 10 power minus 27. The charge of electron is minus 1.6 into 10 power minus 19 coulombs. 19 coulombs. And mass of electron is equals to 9.1 into 10 power minus 31 kg. Minus 31 kg. Now coming to the proton. Proton is equals to plus 1.6 into 10 power minus 19 coulombs. Plus 1.6 into minus 19 coulombs means the same charge on proton and same charge on neutron, so they are getting to neutralize each other. Now mass of proton is equals to 1.6 into 10 power minus 27 kg. Minus 27 kg. This is the mass of proton. And coming to the neutron, there is no any charge. Okay. Neutron means there is no any charge, so neutral in nature. Mass of neutron equal to 1.675 into 10 power minus 27 kg. This is the electron, proton, neutron. These three are present inside the atom. Where it is present, how they are arranged, and what is the stability, everything we are going to know about the atom in atomic model. What is atomic model? Atomic model means atomic model. Atomic model. Atomic model means arrangement of electrons, protons, neutrons in an atom. In an atom is called as atomic model. We have so many atomic models, so many scientists are explained about the atom and about their electrons, protons and neutrons, how they are arranged in an atom. They given so many models. We are going to see three models. One is J.J. Thomson atomic model. J.J. Thomson atomic model. Another one, Rutherford atomic model, Rutherford atomic model, and third one atomic model, Bohr's atomic model. These three models we are going to see now, right? Atomic model, J.J. Thomson atomic model. J.J. Thomson atomic model, also called as watermelon atomic model. Watermelon atomic model. Why we are calling as a watermelon atomic model? Because he uh, he compared atom as in the shape of watermelon, in the shape of watermelon, and inside the watermelon what are present? Inside the watermelon what are present? Seeds are present, seeds, and a red color pulp. A red color pulp is present in the inside of watermelon. So he compared an atom is just like as a watermelon. What are the seeds are present? Seeds are present in the watermelon in randomly. There is no any order. Orderlessness is there for the seeds. Seeds he compared with electrons, means in an atom electrons are arranged orderlessness. Wherever they want, they can takes place. So seeds are arranged like as electrons are arranged like the seeds of watermelon, and red color pulp he compared with the protons. Red color pulp he compared with the protons, means the red color pulp is occupied throughout the watermelon, like that the positive charge occupied throughout the watermelon. So what is the J.J. Thomson atomic model? Atomic model he compared with watermelon. Watermelon, how the watermelon is there? That is the shape of atom, and electrons, where the electrons are present, like as seeds of the watermelon he arranged in the fruit, and electrons are arranged in an atom like the seeds of the watermelon, and the positive charged protons are arranged throughout the, they occupied throughout the space of the atom, like as how the red color pulp are occupied throughout the fruit. This is about J.J. Thomson atomic model, but it is a failure atomic model. Failure atomic model. What is the reason? He doesn't explain clearly about the atomic model, atom, how it is arranged, what is the reason, everything he couldn't explain. And another one, where is the neutrons? He couldn't explain about the neutrons. These are the failures of J.J. Thomson atomic model. After J.J. Thomson atomic model, we have one more atomic model. It is closely successful atomic model, that is Rutherford atomic model. Rutherford atomic model. Rutherford atomic model is having one experimental evidence. He done the alpha ray scattering experiment. Alpha ray scattering experiment. Alpha ray scattering experiment. I will explain what is the alpha ray scattering experiment. This is gold foil, gold plate, or otherwise you can take as a gold plate, and he passed the alpha rays. Alpha rays are coming from a beam, light beam. This is we can call as a light beam, which produce the alpha rays. Alpha rays are passing through the gold foil or gold plate, and he arranged the screen. This is a screen to observe the experiment. And he observed 3 points. He observed 3 points. Number one, most of alpha rays are passing in straight line. Most of alpha rays are passing in straight line. Second one, few of rays are falling on the screen, by making some angle, and third point, very few of rays are reflecting back, means they are going back, reflecting back. These 3 points he observed from this experiment. He observed 3 points. Alpha rays are passing in a straight line. Most of alpha rays are passing in a straight line. And second point, very few of rays are falling on the screen by making some angle. If you observe, it is making some angle. And third one, very few of rays are reflecting back, means they are passing, they are going through to the screen and they are coming back. These are the 3 points he observed, and he is giving the what is the experimental reason for this one. Very good reason also he has given. Number 1, what is the reason for most of the rays are passing in a straight line? Because atom is having most empty space. So in an atom, most of the space is empty, so that alpha rays are passing in a straight line. And second reason what he has given, because a few rays are fall, because atom is having a smallest area with some charge. Due to that, when the rays are passing through the atom, due to that area, they are reflecting and changing their path, so that they are making some angle on the screen. So what is that area? That area is called as a nucleus. Who discovered the nucleus? Rutherford discovered the nucleus. So center of the atom is called as a nucleus. The area is there which occupy a center of the atom. That area we are calling as nucleus. That nucleus, what are present in the nucleus? Protons and neutrons are present in the nucleus. We know that protons are with a positive charge, neutrons are there is no any charge. So the overall charge on the nucleus is positive. So the area is having positive charge. When these rays are reaching that area, they are reflecting with some angle. That is the reason. So now inside of the nucleus, what are present? Protons and neutrons are present. Combiningly, these two are, protons and neutrons are combiningly called as nucleons, because they are present inside the nucleus. This is the reason for second point. And what is the reason for the third point? Very few rays are reflecting back. What is the reason? Because some particles are there, some charged particles are moving continuously, so that so the reflection happens. What is the meaning of this one? Because some charged particles inside apart from the nucleus, again some charged particles are present, they are continuously on movement. So based on all these 3 points, he given the conclusion. He given that these are the reasons. He given one good conclusion about this one is atom is in spherical shape like this. Atom is a spherical shape and center of the atom is called as a nucleus. Center of the atom is called as a nucleus, which is containing protons and neutrons. So the overall charge on nucleus is obviously positive charge. Around the nucleus, some charged particles are revolving. Some charged particles means nothing but electrons or revolving around the nucleus. Revolving around the nucleus. Like how the planets are rotating around the sun. He given the conclusion. Atom is in spherical shape, center of the atom is called as a nucleus, and around the positively charged nucleus, electrons which are having negative charge. So negatively charged electrons are rotating around the nucleus, like how the planets are rotating around the sun. Planets are rotating around the sun. Planets are rotating around the sun means, what is that? A solar system around the sun. That is solar system. So he compared his atomic model with the solar system. Till now it is very successful theory, but here he couldn't explain about the stability of atom. So he compared his atomic model with the solar system. So this model also called as a planetary model. Rutherford planetary model of an atom. Rutherford atomic model also called as a planetary model. If we are taking J.J. Thomson model, is called as watermelon model. This is a planetary model. Okay. Now, what is the drawback? So, he compared, he done the good experiment, he got the result also, but where is the failure is he couldn't explain about the stability of atom. And one more thing is why he compared his atomic model with planets. Planets are revolving around the nucleus. Planets are revolving around the sun in particular orbits. Okay. But here electrons are revolving around the positively charged nucleus. Electrons are negatively charged. Nucleus is positively. When any charged particles are continuous moving means some heat energy means in the form of we are calling as a radiation, radiation will be released. Radiation means nothing but heat energy in the form of heat. Energy is releasing in the form of heat. If any charged particles are continuously moving means that they will release some heat energy. So that if we are taking any continuous flow of current, if we touch the wire, we feel heat. Or otherwise, mobile also. Mobile if we are taking means we feel heat because of radiation. Radiation means they release some heat energy. Means inside of that charged particles are present. So the continuous using movement of charged particles, they are releasing some heat. Because of releasing the heat, and they may gain the energy or release the energy. If they are gaining the energy, no problem. They will go for higher energy level. If they are releasing the energy, they will fall on the atom, fall on the nucleus. Then the atom is going to be collapsed. How the stability became for the atom, he couldn't explain. And now the point is how the planets are revolving around the sun. Planets are revolving around the sun without losing the energy, without gaining the energy, isn't it or not? They are not falling on the sun. Why? Why happened in the solar system? Why it is not happening in the atom? Because planets are neutral particles. There is no charge on the planets, so that they can rotate for a long time. But electrons are charged particles. Charged particles are continuous moving, means they can release or gain some energy. If they are losing the energy, they may fall on the nucleus. How they are not falling on the nucleus? Continuously they are rotating. Why they are rotating? What is the reason? This type of things he couldn't explain, so that this was the failure atomic model. But he is very near to the success. He is very near to the success, and he discovered the nucleus also. They may ask the question about the nucleus. Who discovered the nucleus? Rutherford. After that, Bohr's atomic model. What is the successful theory? Till now we are following. Now Bohr's atomic model. In this Bohr's atomic model, he explained, number one, atom is in spherical shape, same just like as a Rutherford atomic model. Atom is in spherical shape, means like this. Atom is like this. Center of the atom already Rutherford discovered, so he also supported that one. It is also having the center of the atom. It is also having the center of the atom. So they are in the center of the atom, we are calling as a nucleus. Nucleus is containing protons and neutrons, so the overall charge on the nucleus is positive charge. That we know very well. After that, and electrons are revolving. Electrons are revolving around the nucleus with in particular path, circular path, which are called as orbits. I will give capitals to the orbits. Y means indicates with capital K, L, M, N, and so on. K, L, M, and so on. So they are having particular path around the nucleus. In that particular paths, electrons are revolving, and these paths are having some fixed energy, so they are called as stationary orbits. So now he is in safe zone. Stationary orbits. What he explained after explanation of Rutherford and his failure, he said that these paths are having the particular energy, some fixed energy. So electrons are having some energy to move. The minimum energy, how the electrons they are having, with that minimum energy they can rotate in first shell. Are you understand? Means in first shell, what energy they need, that energy is the minimum energy of electron. So below that energy, electron does not exist. So with minimum energy, they can rotate in first orbit. If they are gaining the, we said that electrons are revolving around the nucleus, means they may gain the energy or they may lose the energy. If they are gaining the energy, if they are gaining the energy, they can go for higher energy level. This one. Next energy level means this is K shell, this is L shell, this is M shell, this is N shell. So if they are losing the energy, they can go for lower energy level. If electron gains some energy, they jump from lower energy level to higher energy level. If they are losing the energy, they jump from higher energy level to lower energy level. In first orbit, they cannot lose the energy because that is the minimum energy of electron. So, like this, he explained about the energy of orbital. Every orbit is having some fixed energy, so that these orbits are called as stationary orbits. Stationary orbits means the orbits with fixed energy. So, now what is the fourth point? If electron gain some energy, gain the energy, they jump from higher energy to lower energy, and if electron release some energy, means they lose some energy, it jump from here gain energy means lower energy to higher, lower to higher energy. If electron release, if it lose the energy, it jump from higher energy to higher energy level to lower energy level. So from this way, so the total energy change in the energy between the orbits, change in energy between the orbits equal to E2 minus E1, higher energy orbit minus lower energy orbit. You can get the energy of orbit. Now this is center of the atom. Around the center we have orbits. These are the orbits. First orbit is called as K shell. K shell means first orbit. Second orbit L shell. Third orbit M shell. Fourth orbit N shell. Now electron is revolving around the orbit with minimum energy, that is first shell. By rotating, it is gaining some energy. They can jump from lower to higher. Here also, if they are gaining the energy, they can jump. Here also, or otherwise. By rotating, if it loses, it can come to here. If it loses, it can come to here. If it loses, it can come to here. Here it cannot lose because here it is the minimum energy. I hope you understand. So, we can understand that the energy which is near to the nucleus, the shell or orbit, both are same only, shell or orbit. So, the energy of orbit which is near to the nucleus, that is less energy orbit. Less energy orbit is near to nucleus. Higher energy orbit is far from the nucleus. So they may ask the question, in K element which is having the less energy, K shell. In K element which is having the more energy, obviously N shell, which is far from the nucleus, they are having the higher energy. which is very near to the nucleus, it is having less energy. This is a Bohr's atomic model successful theory what we are following till now. Right. So from this we can understand that electrons are revolving around the atom in circular paths, which are called as orbits. So circular orbit means that is having some angular momentum. So angular momentum will be there. Angular momentum will be there for this circular path. What is angular momentum? Because mass, velocity and radius, MVR, mass into velocity into radius. Who are rotating around the nucleus? Electrons. Electrons are having some mass, so mass of the particle. V, velocity, they are rotating with some speed, and R, radius of the orbit. If we are multiplying with these three, we will get angular momentum, that is equals to nh by 2 pi. nh by 2 pi. N means a principal quantum number. What is that? Means number of shell. H means Planck's constant, 2 into pi. This is angular momentum. And he explained, who? Bohr's theory explained about the spectrum. Explained about the spectrum. What is meant by spectrum? Spectrum means we know very well about colors, VIBGR. If a light passing through the prism, light means nothing but light particles will be there. Light particles means nothing but atoms only. Means atoms, when they are passing through the prism, it splits into 7 colors. 7 colors. That is called as a spectrum. So he explained how the atoms enter into the prism, it splits into colors. He explained about the spectrum. And failures of Bohr's theory. Number 1, he couldn't explain all type of atoms spread. He couldn't explain the spectrum for all atoms. I think, or you understand? Means here whatever atoms he has taken only for hydrogen or helium or lithium. That too, helium He plus lithium He plus 2. Means who are having only one electron. Who are having only one electron. Hydrogen, if you take, we know that what is a hydrogen atomic number, that I will explain. One electron only. Helium actually, what is the atomic number? That many electrons will be there. So 2 electrons. But he has taken He plus. Plus means loss of 1 electron. 2 electrons minus 1, we will get 1 electron only. Lithium, Li plus 2. Lithium atomic number 3. Number of electrons equal to 3 electrons. And 2 electrons already lost, so 1 electron. So he has taken the atoms which containing only 1 electron. He explained about the spectrum which containing only 1 electron atom, but he couldn't explain about the spectrum for all atoms. That is his failure. And spectral lines, splitting of spectral lines means splitting of spectral lines. He couldn't explain about splitting of spectral lines. Means if we are taking this spectrum, some deflection will be there, some disturbance will be there. Actually, we can use that word. Some disturbance will be there when we are applying the electric field and magnetic field. electric field and a magnetic field, if we are observing, some disturbance will be there in the spectrum. Why that is disturbance is there? That he couldn't explain. That we can use the word splitting of spectral line. He couldn't explain about the splitting of spectral lines. This is Bohr's atomic model and his success and failures of the theory. After that, atomic number. Atomic number. Every element, if we are taking every element from hydrogen to 118 elements, whatever elements if you take, those elements are having atomic number what we are indicating with Z. Atomic number we are indicating with Z. Z is atomic number, and atomic number is equals to the number of electrons. Number of electrons in atom. Number of electrons in atom. And this Z also equals to the number of protons in atom. I already told you the overall charge on atom is neutral, because it is a neutral atom. Number of electrons, the what is that? Number of positive charge is equals to the number of negative charge. So the atom overall charge on atom is neutral. So for neutral atom, if you take atomic number, number of electrons, number of protons, both are is equals to the number of atomic number. After that, atomic mass. Atomic mass. Mass of the atom. Mass of the atom is depends on nucleus. Nucleus means we know that protons and neutrons. Protons and neutrons. So atomic mass we are indicate with the letter is equals to protons plus neutron. Protons we are taking as atomic number Z plus neutrons. So number of neutrons equal to number of neutrons is equals to A minus Z. Now are you, I think, are you understand? Number of electrons equals to atomic number. Number of protons equals to atomic number. Number of neutrons equals to atomic mass minus atomic number. For example, we can calculate for magnesium. Magnesium, which is having the fixed atomic number, fixed mass number also. So, what is the number of electrons? Number of electrons equals to 12, because it's atomic number. Number of protons equals to that also 12, because it's atomic number. Number of neutrons equals to 24 minus 12. Atomic mass minus atomic number, that is also 12. That is also 12. If number of electrons is equals to the number of protons, there is no any charge on atom. Is there any charge? No. For example, if we will see one charged particle, for example, Mg plus 2. Mg plus 2. Whenever it may be positive charge. Positive charge is there means, remember this one, it is very important. Positive charge means loss of electrons. Electrons are lost. How many it is lost? How much number is there with a positive charge? That many electrons are lost. And negative charge. Negative charge. Negative charge means gain gain of electrons. Gain of electrons means how much? How much charge is there? That many electrons are gained. For example, N minus 3. What is the meaning? 3 electrons are gained by nitrogen. Mg plus 2. 2 electrons are lost by magnesium. And positive charged ion we are calling as cation. Negative charge ion we are calling as anion. So, how many types of ions are there? Now we are clearly we discussed about ions, I think so. Ions, number, what is the meaning of ion? Ion means charged particle. Ion means charged particle, right? How many types of ions are there? Two types of ions. One is cation, one is anion. Anion means which is having the positive charge. Positive charge means because of loss of electrons. Positive charge is formed by the loss of electrons. Negative charge, anion. Anion means negative charge. Negative charge means due to the gain of electrons. If it gain the electrons, we will get the negative charge. For example, we will see. Example, Mg plus 2. We already Mg plus 2. Mg we already find out for Mg all are electrons, protons, neutrons, all are is equals to the 12. Right, not all combinedly, individually they are 12. Now, coming to the magnesium 12 and 24. If you take, this is an atom, this is an atom, always atomic number at down of the element, atomic mass at top of the element. This is the indication of an element along with atomic number and atomic mass. Now, coming to the number of electrons in magnesium, obviously 12 because of atomic number, but some charge is there. So, 2 electrons are lost, positive charge is formed by the loss of electrons, so 10 electrons. Coming to the protons, protons means 12. Neutrons means 24 minus 12. Neutrons means you can write as A minus Z. A minus Z means here number of protons, not number of electrons. That you need to remember, because atomic mass due to the because of protons and neutrons. So you should not write here 10. That you need to remember. And here if you take electrons 10, protons 12, neutrons also 12. I hope you understand how to calculate the number of electrons, protons and neutrons. So one more example we will do for n minus 3. N minus 3. This one. Yeah. N minus 3. N is nitrogen. Nitrogen means atomic number 7. Atomic mass is 14. Atomic mass is 14. Number of electrons is equals to actually 7. But due to the minus 3 means anion. Anion means gain of electrons. How many electrons it gain? 3 electrons. So total is 10. Total is 10. Protons is equals to 7. Neutrons equals to 14 minus 7 equal to 7. Here atom is this one. Electrons are revolving around the nucleus. If we need to remove the electrons or gaining of electrons only takes place, protons there is no any change, because protons are present inside the nucleus. From inside the nucleus, if you want to remove the protons and if you have to add the electrons, that is highly impossible. So there is no change in protons, only electrons can be changed by gain and loss of electrons by forming the ions. I hope you understand. After that, isotopes. We heard about isotopes and isobars. If you remember drawbacks of, we already discussed about isotopes and isobars in Dalton's atomic model. Dalton's atomic model does not explain about the isotopes and isobars. What is the definition of isotopes? Isotopes means the atom which has same atomic number is same atomic number and different mass number. For example, atomic number we are indicating with Z, mass number we are indicating with A. Very good example, H11, H12, H13. This is isotopes of hydrogen, what we are calling as protium, tritium, sorry, this is a deuterium, this is a tritium. For our convenience, this we can write as H11, D12, T13. Obviously, this is nothing but H11, H1. If you observe, the atomic number of these three is the same. So, atomic number is same means automatically atom also same. Means the same hydrogen, hydrogen, hydrogen. If you write D or T also, this is hydrogen only. Mass is different. Mass is different. Same number of, same atomic number for the same atom, but which is having different mass number, that is called as isotope. One more example for isotopes, example number 2 is C612, C614, C613, C614. This is a carbon isotopes. There is no any another name. These are called as hydrogen isotopes, carbon isotopes, even though nitrogen also having isotopes. We should not write for every atom for with our convenience by writing the different mass number. We cannot create like that. Whatever existing in the universe, that only we need to write. So these are, if you observe, only for H11, H12, H13, we will say number of electrons equal to 1, protons equal to 1, neutrons equals to 0. Right, 1 minus 1, 0. Right. Here electrons equal to 1, protons equal to 1, neutrons equal to 1. Right. Here electrons equal to 1, protons equal to 1, neutrons equal to 3 minus 1, 2. So we can call as isotopes also, which are having same number of electrons and protons, different in the number of neutrons. The atoms with a different number of neutrons, they are called as isotopes also. Another definition also we can give, the atoms with same number of electrons and protons and different number of neutrons. Right. Here I want to explain about H11 alone. Generally, these two we are not using in our regular purpose. This only we are using in our regular, wherever if you want to write hydrogen H2O, that hydrogen is this only, not about deuterium and tritium. So regularly we are using this one. If you remove one electron from this, one electron if you remove, this is converting as H plus. Is it right? H plus, right. For this H plus, atomic number 1, atomic mass also 1. Number of electrons equals to actually general number of electrons 1. Already by loss of 1 electron, we will get 0. Proton 1. Neutron 0. So H plus ion we are calling with the name of proton, because in H plus ion there is no electrons, there is no protons. If you remember in acid, base and salt lesson, acid means which release H plus ion, I said. Which release H plus ion. H plus ion means nothing but proton. In higher classes you may get it. H plus ion means nothing but proton. Why it is a proton? Because here proton only present. Only one proton is present. There is no electrons, there is no neutrons. So proton we are indicating with H plus. H plus we are calling with the name of proton. I hope you understand. Next, isobars. Isobars is just reverse for the isotopes. Isotope means same atomic number, different mass number. Here different. Here reverse. The atom with same mass number and different atomic number. number. For example, we have the isotope of C614 isotope also there, N714, normal nitrogen. They are having same mass number, different atomic, different atomic number means they are also different atoms. If you check a number of electrons 6, protons 6, neutrons 14 minus 6, 14 minus 6, 8, 8. Here, number of electrons 7, protons 7, neutrons 7, 14 minus 7, 14 minus 7. So, different number of electrons, protons, neutrons will be there in isobars. One more example is there, potassium 1920, calcium, sorry, 1939, okay, it is not example. Argon 1840, calcium 2040, calcium 2040. If you take electrons 18, protons 18 and neutrons 40 minus 18, I think 22. Number of electrons 20, protons 20, neutrons 20, 40 minus 20, 20. So, different number of electrons, protons and neutrons will be there in isotopes. If you check with isotopes are having different number of electrons and protons, but same number of neutrons will be there. No, same number of electrons and protons, different number of neutrons will be there in isotopes. In isobars, all are different. Next, isotones. Isotones means the atom with same number of neutrons. The atom with same number of neutrons is called as the atoms with same number of neutrons are called as isotones. For example, if we take argon 1840, potassium 1939. Atomic mass of potassium is 39. Electrons, we don't want electrons and protons because in its definition itself same number of neutron. Neutron alone we can check 40 minus 18 is equals to 22. Here, no, not argon, sorry, calcium 2040. 40 minus 20 is 20. Here, number of neutrons 39 minus 19 is equals to 20. So, same number of neutron. Now, these two we are calling as, these two atoms we are calling as isotones. Isotones means we don't want to compare with the number of electrons. Obviously, number of electrons, protons are different only. Same number of neutrons should be there. Same number of neutrons containing atoms we are calling as, this set we are calling as isotones. This is about isotopes, isobars and isotones. Next, quantum numbers. 1 minute. Numbers. And these quantum numbers gives the complete information about electron. Gives complete description about electron. Where is the electron? About electron. Where is the electron? Electron is revolving around the nucleus in particular shells. Is it correct? So, how they are rotating, where they are rotating, that we are we are knowing about the electron in these quantum numbers. 4 types of quantum numbers are there. 4 types are there. Number 1, principal quantum number. Principal quantum number. Principal quantum number given by Bohr. Given by Bohr. This is indicates, it indicates number of shell. Shell or orbit both are same. I already told you which we are indicating with K, L, M, N and so on. It principal quantum number indicates with the letter N. Principal quantum number indicates with the letter N. For example, this is an atom. Around the atom, shells are there, where the electron is rotating. That is the that we can in K shell or L shell or M shell. In which orbit electron is rotating? For K shell, N is equals to 1 because first shell. For L shell, N is equals to 2 because second shell. N is equals to 3. Based on the number, we can find out, based on the number of N, we can find out. For example, 2s2. What is a 2s? That we are going. 2s is there, where the electron is revolving, because this indicates the what is the number is there, that indicates the number of shell, means electron is present in second shell. Electron is rotates in second shell. That we can find out by using principal quantum number. So, principal quantum number indicate with N given by Bohr, and it indicates the number of shell where the electron is rotating. Now, the last point in principal quantum number, the number of electrons, the number of electrons present in shell is equals to 2n square. For example, first shell if you take, for example, K shell. K shell means N is equals to 1. How many electrons it can exist? 2 into 1 square is equals to 2. Means in K shell, it can accommodate 2 electrons only. Right. In L shell, N is equals to 2. 2 into 2 square. 2 square means 4. 4 into 2, 8. 4 into 8. To 8. So, in L shell, how many electrons it can accommodate? 8 electrons. And M shell, if you take M shell, N is equals to 3. 2 into 3 square. 3 square means 9. 9 into 2, 18 electrons. Like that, we can find out the number of electrons in the shell. How many electrons they can accommodate in a shell? All the shells are not having same number of electrons. Based on their energy and existence, they are accommodate the electrons. So, K shell can accommodate 2 electrons, L shell can accommodate 8 electrons, M shell 18 electrons. Like that, if you count for N, M, N, O, we will get a different number of electrons. After that, second quantum number is azimuthal quantum number. Azimuthal quantum number, which indicates with the letter L. It was introduced by Sommerfeld. Sommerfeld, he also given one more information about the atom. Actually, according to the successful Bohr's theory, we are saying that atom, around the atom, electrons are revolving around the nucleus in circular orbit. So, orbit is in spherical shape. But Sommerfeld was given, but that was failure, eclipsed. He given eclipsed shape for the atoms. Eclipsed shape for not atom, orbit. For orbit. We don't want that theory and all, just the information. According to him, orbits are in eclipsed shape. There is no any relation between this and this. This is different, that is different, right? Coming to the azimuthal quantum number. Azimuthal quantum number gives the information for subshells. Very important, subshells. What is subshells? Actually, this is a shell, first shell, second shell, third shell, and fourth shell also will be there, right? First shell also having subshell. Under the behalf of first shell, again one more subshell will be there. Okay, and that we are indicating with S. And second shell is a behalf of second shell, subshells will be there. That subshell, in these subshells only electrons are revolving. Means we are at home, means at home so many rooms will be there. Like that, in behalf of orbit, subshells will be there. That's all. No need to think about this. What is the subshell? And electrons are revolving in the subshells behalf of shells. That's all. This is S and P. Like that, third subshell also having three subshells. These subshells we are indicating with the letters, small letters S, P, D, F subshells. S, P, D, F subshells. These are also called as orbitals. S orbital, P orbital, D orbital, F orbital. They are KLMN, they are orbits. These are orbitals. That is the difference. Now, coming to the orbitals. First shell is a K shell. If we take L value is equals to 0 to n minus 1. 0 to n minus 1. This is the rule for formula for L value. Now, if you take a K shell L is equals to 1. So, the L value is 0. Obviously, 0 to n minus 1, 0. And n minus 1, 0. So, obviously 0. And L, for L, n is equals to 2. L value 0 and n minus 1, 2 minus 1, 1. 0, comma 1. 0, comma 1. And n is equals to 3. Visible? N is equals to 3 means L value 0, 1, 2. 0, 1, 2. These all are subshells. Means what is the meaning? Meaning first shell is having only one subshell. One subshell. Right. Second shell is having two subshells. Two subshells. Third shell is having three subshells. Three subshells. I hope you understand. Three subshells. With this, we can explain. So, if k equal to k, n equal to 1, we are having L value 0, L value n equal to 2, L value 0, 1, n equal to 3, L value 0, 1, 2 we got. Now we said that K is having only one subshell, that is S. Subshell name means we are indicating with the letter S. This one S and P. This name, why again S? Because it is present in first shell, it is present in second shell. Always they are indicating with SPDF only. We should not give one more letter like as A, B, C, D up to Z. So, this is again SPD. You may think that how we can find out this is. You can give the number, no problem. It is in first shell, so you can call as 1s. This is in second shell, this is 2s and 2p. This is in third S, 3s, 3p, 3d. Now there is no any difference. There is no any confusion. Now if you go for n shell, n is equals to 4 for capital N. N is equals to 4 means L value would be 0, 1, 2, 3 up to n minus 1, right? So for this, what would be the name? 4s, 4p, 4d, 4f. If you observe clearly here, azimuthal quantum number L value for s orbital. Always you can observe L value for s orbital. In each case, you can observe L equal to 0. For s orbital, L equal to 0. For p orbital, L equal to 1. For d orbital, L equal to 2. For f orbital, L equal to 4. 3. Okay, I think are you understand? So, azimuthal quantum number, what it indicates? It indicates the subshells. How many subshells are there in the shells? Shells are also having subshells. Orbits are also having orbitals. Both are same. Two definitions are same only. So, shells having subshells, orbits or having orbitals. What we are indicating with SP, D, F. So, these subshells, how many are there for each shell? What are the azimuthal quantum number indicating by azimuthal quantum number? Who was given this one? Sommerfeld. Right. After that, third quantum number, magnetic quantum number. Magnetic quantum number indicates with a small m. Indicates with a small m. This magnetic quantum number gives the orientation of orbitals, not orbits. Orbitals means SPTF. Orientation means how many orbitals, how they are divided. That we can explain by using magnetic quantum number. So, we know that m is equals to minus L2 plus L including 0. Including 0. Including 0. For example, if you take I will write from principal quantum number, n value, L value, m value. Okay. Why? No need. L equal to 0. For s orbital, no, this one. For s orbital. No doubt about this. For s orbital, L value 0. Obviously, m equal to 0. Because m equal to minus L2 plus L. This you need to remember. Means s orbital is having only one orbital like this. For our convenience, orbital is writing as a box, which is having m value 0, L value 0. Okay. For p orbital, L equal to 1. Obviously, m value minus 1, 0, plus 1. 3 values, no? Minus L2 plus L. So, p orbital is having 3 values. So, it is dividing as 3 orbitals. Plus 1, sorry, minus 1, 0, plus 1. You should not write here plus 1, here 0. No, this is the order to write minus 2 plus. That's all. And a d orbital. 2. 0, 1, 2, right. Minus 2, minus 1, 0, 1, 2. Means how many values are there? 5 values. Means it is divided into 5. It is divided into 5. Like this. Means -2, -1, 0, 1, 2. That's all. And if you take F orbital, this is called as orientation, means how they are dividing. 3. 3 means -3, -2, -1, 0, 1, 2, 3. So it is divided into 7 parts. One, two, three, four, five, six. -3, -2, 1, 0, -1, sorry. -1, 0, 1, 2, 3, 6. So this is the orientation of orbit. Okay. Last I will explain about spin quantum number. Last quantum number, fourth one, spin quantum number. It is indicating with small s. It is indicating with small s. This spin quantum number gives the rotation of electron. Means wherever it may be, electron rotating means not only electron, whoever it may be rotating means either clockwise direction or anti-clockwise. Clockwise direction, if electron in clockwise direction. If electron in clockwise direction, it is plus half. The value is a plus half. If electron is in anti-clockwise direction, that is minus half. Means plus half and minus half, if we are indicating the electrons like this. Electron is in up hook arrow, that is having plus half spin quantum number. If down hook arrow, that is means like this also we can indicate, no problem. But when we are writing the electrons, we will write like this only. Either this or this. Or this also you can indicate, minus half. Minus half. So this is a spin quantum number and a magnetic quantum number. How we are using that we are going to see now.